Satyabama Institute of Science and Technology.
Welcome to Sathiyaraj video lecture series. My name is Dr. A Sathiyaraj. I am from the Department of Information Technology. Today I am going to discuss about the topic is queue data structure. The list of content, definition, queue data structure, terminology, example, program and application of a queue. Queue data structure definition. It is one of the most important linear data structure. It is working based on the principle of first in, first out. So, whatever the element we are inserting first, that element should be deleted first. So, real time example, if you are going to the cinema theater, if you want to buy a ticket, you need to be enter into the queue. If you entered first, you will get the ticket first. If you are entering the last, you will get the ticket last. So, that is a real time example for the queue data structure. Then there are two pointers are there, rear and front pointer. So, usually the data structure, we are going to be inserting the element and deleting the element. For inserting the element, we are using the rear pointer, deleting the element, we are using the front pointer. So, this is the example of data structure of a queue. It is a empty data structure, there is no value inside the data structure. So, it is also called as the initial data structure. So, you can see front and rear equal to -1. So, this is the initial condition for the queue data structure. Terminology, list of terminology, front, rear, underflow, overflow, EnQueue, DeQueue, searching. Front, it is a pointer used to be delete the element from the queue. Rear, it is a pointer used to insert the element into the queue. Underflow and overflow, there are two conditions are there. Before inserting and deleting, we need to be check the condition. If you want to delete the element, the queue supposed to be contain some value. If you want to insert the element, the queue has some empty spaces, or if it is the queue is full, we cannot insert the element. So, underflow condition, checking the empty. So, it is the condition before deleting, we need to be check it. Overflow condition, it is the condition before inserting, we need to be check it. EnQueue, that is the operation to insert the element into the queue. DeQueue, it is the operation deleting the element from the queue. Last one is the searching, to find the element from the queue. Front and rear pointer. You can see the example of data structure. The previous slide I explained the initial data structure, that is what front and rear are outside, that is front and rear equal to -1. That means initial there is no value. So, here you can see front indicating the A, rear indicating the C, R and F is the short form of front and rear. So, according to the data structure, number of locations or size of the data structure is 5, but according to the location started from the 0 up to the 4. So, present front is locating the 0, rear locating the 2. So, total overall size is 5. So, front is the pointer to keep tracking of the first or starting of the element in the queue, and it is used to delete the element based on the principle of first in, first out. Similarly, rear, it is also working based on the first in, first out, but in the rear we are going to be inserting the element EnQueue. EnQueue, it is the operation, we are going to be do the EnQueue, it is the operation to insert the element into the queue based on the principle of first in, first out using the rear pointer. Before inserting, we need to be check whether the queue is full or not. Before inserting the element into the queue, we need to be check whether the queue is full or not. If it is the full, we can't able to insert the element. So, here you can see the data structure example, the particular queue is full. So, that means what? The rear pointer is indicating the last location. The last location is 4. So, overall size is 5. So, here you can see the condition, if rear equal to size -1. Size is 5, the number of locations is 5, but the location indicating 4. So, that is why 4 that is a 5 minus 1, rear equal to size -1, that means what? Rear 4, size -1, 4, both are 4. Now, the condition is satisfied, then we are printing the message, print queue is full, insertion is not possible. Then coming to the next step, if the queue is not a full, then automatically if condition is not satisfied, then it is coming into the else part. In the else part, we are going to be checking if front equal to -1. Okay, we used to be insert the element with the help of rear, not with the help of front. So, we need to be use the rear to insert the value, but initial queue we need to be check front equal to -1 or not. That means what? Initially front and rear are equal to -1. So, once we inserted the first element, we need to be push the front into the 0 position, 0 position. So that's why before inserting, we have the condition front equal to minus 1, then we are changing the front value into the 0th location, then we are incrementing the rear from the minus 1 to 0 it is locating, then q of 0 equal to value. Whatever the value we are going to be inserting, that value is available here value that is inserted in the q of 0 location. So it is going to be inserting here. So initial position minus 1, then rear also minus 1, the overall size is 5. That is what I written here. Then coming to here. So here the next one, the q contain the 3 element, the q contain the 3 element. Here you can check it, else if front equal to minus 1. So condition is not satisfied because front equal to 0, front equal to 0. So that means what? Already it has some value, it has some value. Then the condition is not satisfied. So front equal to 0 is not going to be execute directly. It is coming into the rear plus plus. So that means what? Present rear is indicating the second location, that is the C data. Then after incrementing this one, then R becomes moving to the third location, that is here. Okay. Then we are going to be pushing the element, inserting the element into the third location, that is the Q of rear. Rear is presently 3 equal to value, that is the D, equal to value, that is the D, that is what inserted here. Then print insertion is successful. Okay, in the output we can able to understand after inserting the next line we provided the text message here. Then again we are going to be incrementing the rear again here. If you want to insert the number of elements, we can able to insert initially with the 3 value. One we inserted D, again we are going to be incrementing the rear to insert the another value. Right now it is locating into the empty location of 4 after incrementing. Then again we are going to be Q of rear, that is a Q of 4 equal to value. The values we provided 4 here. So we provided here 4th location E here. Then coming to the DQ, deleting the element from the queue. So it is the operation to delete the element from the queue based on the principle of first in first out. Then coming here, before deleting we need to be check the corresponding data structure is empty or not. So if it is empty, we cannot perform the operation of deleting. So initially front and rear equal to minus 1. Okay, so that is the empty queue. That is a condition we are going to be checking here. If front equal to rear, front equal to rear. Okay, why we are not checking the front equal to rear equal to minus 1 means initially it is minus 1. After inserting 2 data and deleting the 2 data also it is empty, but this particular location is locating here. That's why we are checking both the pointers are equal or not, equal or not. If it is equal, then directly we are going to be saying Q data structure is empty, we cannot perform the operation of deleting. Then coming to the DQ continuation, after deleting we need to be increment the front pointer, we need to be increment the front pointer after deleting the A. Present front is indicating A, after deleting the A, the front pointer need to be indicate the B. So that's why we are incrementing here. So initially what we are doing according to the program, else part, according to the program, else part, in the else body, printf deletion percentage D Q. So Q of front. What is the value here? In front there is a value A. So we are going to be simply printing in the output screen. Then we are incrementing the front pointer into the position of 1. So that is what front plus plus. Then you can see right now the A is in the output. Now it is empty. After empty we need to be increment the front pointer to push the next starting element. Next starting element. Okay, so it is moving to B here. It is moving to B here. Right now front equal to minus, front equal to 1. Then again we are going to be checking after each and every deleting we need to be check front and rear both are equal or not. If we are going to be deleting, again you can see B right now we are deleting the B here, again C there we are deleting the C here. Okay, but right now after deleting all the element, the last if we deleted the last element, then front or rear is going to be locate in the same location. So that is what the condition we are checking, front equal to rear. That means there is no value in the queue, then we need to push the front and rear pointer into the initial position. So that is what we are doing here. After checking both are same place, front equal to rear equal to minus 1, front equal to rear equal to minus 1. Okay, so this is a special case. If you inserted 3 element, after deleting the 3 element, we need to push the front and rear pointer into the initial position of minus 1. Then coming to the next one. So here the next operation is searching, finding the given element in the queue, finding the given element in the queue. So in the searching also we need to be check whether the queue is empty or not. If the queue is empty, we cannot do the performance of searching operation. Okay, so that is what we are checking. Same or similar like a deleting. Similar like a deleting. The same condition only I written here. If rear equal to -1, then Q is empty. Then we are going for the next part here, else part. This is a if condition. Else part is here. So checking the A value, compare with the given value, B value, compare with the given value, C, compare with the given value. So all the values we need to be checked one after another, whether the given value and available value both are same or not. Okay, so incrementing or checking each and every value, we are using the for looping. We are using the for looping, where we need to be start checking from the front pointer up to the rear pointer. So that is all the values available in the queue. So you can see here, initializing the variable of declaration variable of integer I, printf q element found at, just a text message in the output screen for I equal to front. So initial value is 0, I less than or equal to rear, that is a 3, that is a 3, I plus plus, I plus plus. Then coming to the next, inside the body of for loop, if value equal to q, initially what is there, front equal to 0, then comparing A and the given value here, if value equal to A means, then automatically it is going to be printing the output. Okay, printing the output, the position, that is a what, 0. What is the value? 0. If you provided the input to find the element or search the element, A means it is going to display. If you provided the D, so here initially front value is A, then we are comparing with the Q of I means A, we are provided the value of D, D equal to A is condition is not satisfied, then if body is print statement, so condition is not satisfied, then coming out of the if body, then again coming to here, now I plus plus, that is the 1, that is the I value becomes 1. Right now we are incrementing again and again, we are doing the looping operation, comparing with the A, comparing with the B, comparing with the Z, comparing with the D. Okay, once both are equal here, condition satisfied, then it will enter into the body of if condition, printf percentage D position slash T. Okay, so percentage D means what? I plus plus. Usually the location started from 0. The number of values saying if the third location, fourth value. So that's why we are providing the I plus plus pre-increment. So if it is located at the third location, we need to be say it is the fourth value. So that's why I provided here pre-increment here. Then this is a full program. So each and every operation and condition I provided in each and every slide the piece of program to understand the entire concept. So this is the overall program. So as usual, C program, the header file we included, we define the size 10, queue size, then void queue, that is a list of operation, that is a list of function I declared here, void search integer queue size front equal to -1, rear equal to -1. So this particular line is global declaration. So this is the overall 3 operation we are doing, inserting, deleting and searching. So EnQueue, DeQueue, searching, totally 3 function declaration I created here. Then we are going to be entering into the void main function, integer value comma choice, clear screen, while of 1. Okay, what it means? We are going to be continuously inserting and deleting operation is going to be continue. So always the while condition is true. So that's why we are providing 1. So usually if you are going for condition, if condition or while condition, if you are going to be giving the condition true, then body will execute until the condition is getting failed. So here we provided while of 1. That means what? Always this particular condition is going to be true. This particular loop is going to be execute again and again. Printf, enter your choice, scanf percentage D choice. Then switch cases here, we are asking the user to enter the choice, which kind of operation we need to be do. Switch cases here, whatever the choice we entered, that is going to be enter here. Case 1, choice 2, choice 3, choice 4. As per the user input, if it is a 1, enter the value to insert, that is the insert operation. Here you can see printf/n menu. So in the output, menu is there. Then next line 1 insert, next line delete 2, 3 searching, then 4 becomes exit. So number 1 option insertion, we are going to be asking the user to enter the value. The user will enter. We are going to be store it into the value. Then EnQueue, that is a function call. Then after function execution, it will return back. The condition is going to be, the particular case is going to be break. Similarly deleting, then exit. Exit is we are going to be terminating the while loop. Similarly, we are going to be checking EnQueue, DeQuue, we are going to be EnQueue, DeQuue we are going to be doing. Similarly, searching we are going to be doing. So you can see the output menu is there, insertion, deletion, searching, execute. Okay, so this particular output we are generating based on this particular printf operation. Then enter your choice. Number 1 is here. Then enter the value 2 is here. We are going to be entering the value 2 into the queue. You can see void EnQueue. If rear equal to size minus 1, rear equal to size minus 1, that means what? Full condition. Okay, then else part condition is fail, then automatically we are going to be doing if front equal to minus 1. Initially the front is minus 1, we are changing the front pointer into the 0, then we are incrementing the rear pointer, it will move from minus 1 to 0, then q of rear pointer, that is what right now after incrementing the rear pointer 0, that is the q of 0 equal to value, whatever the value we provided to, that is going to be inserted here, then printf insertion is successful. Then DeQuue. You can see here before deleting we need to be check whether the queue is empty or not. So front equal to rear, that is a condition already I explained with example, that is a condition is going to be saying the queue is empty. Then if the condition satisfied, we cannot perform the deleting operation. I provided the message queue is empty, deleting is not possible. Or if the condition is not correct or it is failed, then it is coming to the else part, printf deleting %d q of front. That means what? The current front pointer, whatever the value is there, that is displaying in the output. After displaying, front pointer is incrementing. It is going to be locate the next first value. Okay, so if front equal to rear, then we are make it as a initial position of q. Then void search. If rear equal to minus 1, it is also similar to deleting. We need to be check whether the queue is empty or not. Okay, if it is condition true, then queue is empty, we cannot perform the searching operation. If the condition fails, then we are going for else part. We are declaring the variable I, that is for the looping variable. We are started from the searching from the front pointer up to the rear pointer, that is a looping. Then each and every time the looping is going to be executed, we are comparing the given input value, and accordingly we are printing the corresponding value number. Then application for the queue data structure, real-time application. The person will wait in the railway station queue for buying a ticket. If there is a railway station, we are going to be buying a ticket, we need to be stand on the line. The person who is standing first, that person will get the ticket first. Then second one, waiting call on hold for the customer service. If you are making the call to the Airtel or Zamtel, whatever may be the mobile company we are calling, we are going to be getting some voice message that we are holding on the call. According to the sequence the call entered inside, based on that we will getting connect with the customer service person. Related to the computing, first come first serve, that is a job scheduling algorithm in the CPU. Second one, spooling printing job in the printer. Next one is the network buffer. Then one is the memory management. Thank you.